Good morning, friends. Today we'll start with some problems on impulse moment. Theory as well as problems on impulse moment. Yesterday we completed work energy method and also some related problems on that. All the types of problems were solved. Today regarding the, as already every time I told you that there are three methods. One is the DLMS principle, second is the work energy method, and third is the impulse momentum. So when you require to work out acceleration and force, then you should go for DLMS principle. And when you require to work out velocity and force, displacements, then you may have to go for work energy method. Otherwise, if there is requirement of time, velocity, and then you may have to force, and then you may have to go for impulse momentum. So normally in the problems sometimes we used to mention by solve this problem by this method. Then you don't have any choice, you may have to go for that one only. Otherwise, if the no method is mentioned, based on this you identify and apply that particular principle so that your problem can be solved very easily. Now today we'll come to the impulse momentum, okay, method. We are equating the component of the impulse momentum in particular direction is equal to the component of the momentum in that direction. So we have to work out a small equation based on that. That is, as you know from Newton's second law, and also based on that, R is equal to ma. So where I'll take it is instead of F, I'm taking it as R because it is the resultant force about any particular direction, either X direction, Y direction, or any other direction. It is the result. The system of force may be acting on the object. The resultant of that will be acting in a particular direction. In that direction, there is a movement of the object in particular direction. That is R equal to ma. That is based on the Newton's second law. Now, this equation, instead of A, I will replace this one by R equal to m is mass, A is acceleration. Instead of acceleration, I will substitute dv by dt, the rate of change of velocity. Acceleration is nothing but A is equal to rate of change of velocity. The same equation I am substituting here. So that slightly I will modify this one. Then you bring this dt for this side, R into dt is equal to mass into dv. Got some equation for this one. Now, as particular force is acting on an object for a particular amount of time, then that is called impulse acting on that is resulted in the movement of an object with particular velocity. So therefore, when a force acts on an object for a particular time, I will integrate this one, the above equation, zero to t r into dt is equal to mass into, I will integrate from, velocity changes from u to v, mass into dv. When a particular object is applied by a force for a particular amount of time from 0 to t, then that object will have a momentum, achieves momentum and moves in particular direction from u to v. So this equation again I will rewrite this as R, I will take it out 0 to t, as R is fixed, force is fixed, and this is equal to, mass is also fixed, it will not change, u to v and dv. So just you integrate it and you will get R into t is equal to mp minus mu. Either you can write it as mass into the bracket P minus U also. So this is a standard equation. This part, left side part of this one, we call it as impulse. The force and the time of contact of that force on the object, that will result into the impulse, and this is the change of momentum. What is the initial momentum and what is the after moment? After application of this force, what is the moment? The difference of that is mv minus mu, that is change of momentum, where we call it as mass into velocity is called as momentum. So there is a change in the momentum. That is mv is the initial momentum, final momentum, minus this, you can write in this bracket also, final momentum minus initial momentum. So this is the principle we will apply to solve some of the problems where it is associated with time, application of force with certain time. Then we may have to work out time, or you may have to work out the force, or you may have to work out the velocity also. So this equation can be used to solve those problems. Now today we will take up some problems on solving on this topic. So all types of problems will solve it. I will start with some small problem and then we go for all types of problem, just to understand the concept. You take down a simple problem. A glass marble, take down the problem. A glass marble whose weight is 0.2 Newton, falls from a height of 10 meters. A glass marble whose weight is 0.2 Newton falls from a height of 10 meters and rebounds to a height of 8 meters. Find the impulse and the average force between the marble and the floor. If the time during which they are in contact is 1/10 of a second, just I'll explain you what is the problem this is and what they have asked you to determine. They have asked you to determine force exerted on the ball by the floor. This is a floor. You are leaving a ball from a certain height. That height is, the initial height is, the ball falls from a height of 10 meters. You are leaving a ball, okay, from a height of 10 meters, and this is the floor on that it falls from a height of 10 meters, marble ball. This is marble ball falls on the floor from a height of 10 meters and it rebounds in the upward direction to a height of, I'll show it in the dotted lines, okay, height of 8 meters. So during the ball hits the floor and jumps again up, that time the ball is in contact with the floor for time equal to 1/10 of second. It is in contact with the floor and then rebounds by the floor to again at high heights to a height of 8 meters. Now what we want to know that how much force is exerted by the flow. That is what we are required to determine. So in this equation, first of all, I need to know with what velocity when you leave the ball hits the floor. That is, first thing is the velocity of the ball, 1 Newton, weight is given, 1 Newton ball, marble ball, hits the floor. At what velocity it hits the floor at contact with the soil. So that is equal to V is equal to root of 2GH. It is a natural general equation. Most of the times you have used it in your PhD level also. Then you can work out based on that 2 into 9.81 meters per second square into height is 10 meters. You will get the velocity, that is around, you can calculate it, it works out around 14.007 meters per second. That is the velocity with which it hits the floor, and it is in the downward direction. It is hitting the floor and it falls from a height of 10 meters. Now, once it hits with certain velocity, it rebounds back and it becomes zero at a height of 8 meters. It rebounds back to 8 meters height. So that is rebound velocity, I can call it as rebound velocity. Also, I will work out by the same equation 2 into G 9.81. But it rebounds back to 8 meter height. It works out 12.528. It works out to 12.528 meters per second. This point when it rebounds and becomes zero when it hits back off. But when the first ball falls down, that is zero here, it hits the floor. Now, I got both the velocities and also the contact hours. Now, simply I have to substitute all these parameters in the impulse momentum equation. The impulse momentum equation is that R into P is equal to m into p minus u. Now what are the values we take up? R is the force, either you can call it as resultant force or F, whatever you want. P I know it, R I don't know. P is 1/10 of a second is equal to mass is 1 Newton divided by W by G 9.81. 1 Newton is there. Divided by W by G. Weight I want. Mass I want. That weight is 1 Newton. And here the velocity downward I will take it as negative and upward I will take it as positive. When the ball falls down, I will take it as negative. When it moves up, the upward direction I will take it as positive. Now here, when the ball hits this one, it hits with a velocity of 14.07. And when it moves up, that time it will be 12.528. Now I'll substitute upward is 12.52 P, and when it hits that one is taken as minus of U. U is minus 14.007. When it moves up, that is the final velocity, you will get 12.52. When initial velocity is at what velocity it hits the floor is 14 in the downward direction, I have taken as minus. So here the only unknown is R. From this, if you solve it, you will get the answer for R. R is equal to 5.41 Newton. Just you calculate and see the other answer matches with that. So 5.41 is the resultant force acting with which the floor rebounds back the ball. Because of that, the ball reaches to a height of 8 meters. This is how, when the problem related to the time, we can use this one. Now, just you take the definition of what is impulse momentum equation. It is nothing but the explanation of the equation. That is the component of resultant linear, just the definition of this one, impulse momentum equation can be stated as follows. The component of the resultant linear impulse component, the component of resultant linear impulse along any direction is equal to the change in the component of momentum in that direction. Is equal to the change in the component of momentum in that direction. Why you are telling component means a acceleration force may be acting, the ball may be in any direction, but either I may consider in x direction or y direction. The component of that will be taken. So therefore, the component of the impulse about any direction is equal to the change in the component of the momentum in that direction. That is very simple as far as this definition is concerned. So this is how the problems can be solved. We will take up for one more interesting problem. Okay, this one you take it. A 1 Newton ball is bowled to a batsman. A 1 Newton ball is bowled to a batsman. The velocity of ball was 20 meters per second. The velocity of the ball was 20 meters per second horizontally. Horizontal velocity I am telling you. Just before batsman's hit. After hitting it, went away. After hitting it, went away with a velocity of 48 meters per second at an inclination of 30 degree to the horizontal. At an inclination of 30 degree to the horizontal. It is shown in the figure. Find the average force exerted on the ball. Find the average force exerted on the ball by the bat if the impact lasts for 0.02 seconds. Find the average force exerted on the ball by the bat if the impact lasts for 0.02 seconds. Just I will show you the figure. This is a batsman's bat. A ball is bowled horizontally in this direction and hit by the bat, and it moves with an angle in this direction. Here it moves with a velocity of 48 meters per second, I think, and the bowler has bowled with 20 meters per second. This is the initial velocity and this is the final velocity with which it is bouncing back in that direction. This angle it makes is 30 degrees. When the ball hits the bat, it hits in inclined position and it moves with a 48 meters per second in this direction. So, there are two things. When the ball is moving in this direction, inclined direction, okay, 48 meters per second, and this is a horizontal component, and this is a vertical component. When the batsman hits in this direction, I can have two components. One is it is moving in the direction of x, as well as it is moving in the direction of y, and hence it moves in this one. So therefore, this is component along x, Px, force x, and this is a component along y. So along y, that is component of force along this is Py, and we will get the net force exerted on that is P in this direction. We will get the P in which angle he has to apply. This angle alpha, the bat is required to apply force in which angle, so that the ball can move with a velocity of 48 meters per second with an angle of 30 degrees. We have to apply the average force P you are applying. For that I have to calculate component of force in the x direction, component of force in the y direction, and then resultant I have to work out. That resultant is P. That is required to be worked out in this problem. Now in this case, first of all, initial velocity is 20 meters per second with which it hits. First I will calculate the component along x direction, Px, and then I will calculate Py, and then I substitute this one. What are the parameters? The basic equation is R into T equal to M into P minus U. That is the basic equation. First we calculate in horizontal direction. I call it as, in horizontal direction, I call it as Px into T. The time of contact with the ball is 0.02 seconds. That is given with the bat is equal to mass. Weight of the ball is 1 Newton divided by 9.81. Now in this case, I have to calculate with what velocity it moves in this direction, in x direction. Though it is moving in the inclined 30, component of that velocity I will take in this direction. So with what velocity it moves in this direction, that will be taken as it is 48 meters per second in this direction. So component along this will be Px is equal to 48 as per this P is okay. This is 30. This, both will P I will not show it here. This you can take it. Component along this direction is Px. I have shown it only for 4 diagram. Px is equal to 48 into 30 degree cos 30 component along horizontal. It is 48 cos 30. In this direction, it is 48 sin 30 in the vertical direction. So along this direction, the velocity is 48 cos 30, and this is the final velocity, and the initial velocity is 20 meters per second. So first of all, I will write 48 into cos 30 and minus initial velocity, it comes in this direction, is 20 meters per second in the horizontal directions. So therefore, as one direction I have taken positive, this direction I will take it negative. Negative of negative minus 20. So you will get from this Px, force in the x direction, component of the force applied in the x direction by the bat. That works out Px is equal to around 313.81. 313.81 Newton is applied in the x direction. Next is that in y direction, vertical direction, to also work out Py, what is the force applied in the y direction. So therefore, in this equation, same equation, Py into contact is same, 0.02 is equal to the m of same ball divided by 9.81 into vertical direction, the final velocity is 48 sin 30, 48 sin 30 minus, in the vertical direction, as the ball is coming horizontally, it doesn't have any vertical velocity initial. So therefore it is 0. You will get Py in the y direction, that works out 122.32 in the folder. So this is 122.32 Newton and this is 313.8 Newton. Now once I know these two forces, by parallelogram I can work out this angle alpha, I can work out this P also. Now from these two equations, again this answer 1 and answer 2, based on these two, I got P is equal to, in that direction, square root of 313.8 square plus 122.32 square. You will get the resultant force applied by the bat. It works out 336.81. 336.81 Newton is the force applied in this direction. What is that direction? I have to work out that also. 81 Newton is the force applied by the bat in that direction. What is the angle of bat so that it hits on that? That you can get it. Alpha is equal to tan inverse of Py upon 122.32 by Px 3.81. We'll get this one 21.3. This angle alpha works out 21.3 degree. If you hit with a force of 336.8 with an angle of back 21.3 on the ball which is coming horizontally with a speed of 20 meters per second, then the ball moves in angle of 30 degree with a velocity of 48 meters per second. This is how the problem can be, the impulse moment can be applied to solve most of the day-to-day problems. Now we will go to the next problem. I will dictate you. We will take one more problem on that, and then we will go for either this problem or connected bodies. We will go for solving some problems on connected bodies. A 1500 Newton block is in contact, a 1500 block is in contact with a level plane, is in contact with a level plane. The coefficient of friction between the two contact surfaces, the coefficient of friction between two contact surfaces being 0.1. A 1500 Newton block is in contact with a level plane. The coefficient of friction between two contact surfaces is 0.1. If the block is acted upon by a horizontal force of 300 Newton, if the block is acted upon by horizontal force of 300 Newton, what time will elapse? What time will elapse before the block reaches a velocity of 60 meters per second starting from rest? If the 300 Newton force is then removed, how much longer will the block continue to move? How much longer will the block continue to move? Solve the problem by impulse momentum, that is clearly mentioned. So it is a very simple problem. Then have it. This is one block in plain floor. A block is there. Its weight is 1500 Newton. 1500 Newton. It is applied by a force of 300 Newton horizontally. A force of 300 Newton is applied horizontally. This is a floor. The block is rest over a floor, and its initial velocity u is 0, and v is equal to, you require the data they asked you is what is the time required so that the block reaches a velocity of 16 meters per second. When the block will reach a velocity of 16 meters per second if you apply a force of 300 Newton. That is the first step. This is what is asked in the first step, and we have to work out T required to reach V. That is one thing. And second is that if you remove that force after achieving 16 meters per second, how much time it takes to stop it? That is, velocity becomes 0. That one. Second step is that if u is 16 meters per second and v becomes 0 meters per second, what is the time required for this? This is second, this is first. Two things they have asked you. So, when you apply the force, the block starts moving with 16 meters per second, then remove the force, then it will go and stop. Both the time required, they have been asked. The simple thing is that you can simply directly apply the equations. Only thing is that initially you have to work out as the block is moving in this direction, what are the other forces will act. There is a frictional contact between these two, and mu is equal to 0.1 is given in the problem. I think mu is equal to 0.1. Concept is 0.1. So now the normal reaction, as it is on the plane board, the normal reaction is this, and frictional force will be always acting opposite to that as the block moves towards the right side. So therefore, N is equal to 1500 Newtons, very straight this one, and frictional force F is equal to mu into N equal to 0.1 into 1500, you will get 150 Newton frictional force. Now simply you substitute all this. The first stage, time required to achieve 16 meters per second, that is R into T is equal to M into P minus U, the impulse equation. You substitute what are the forces will act in the horizontal direction. 300 force is acting in this direction, I will take it positive, and frictional force F is acting in the opposite direction, I will take it as minus, into T is time required for that, I don't know. And weight of the block is 1500 Newton, I'll take 1500 divided by 9.18 W by G as I want it in this one Newton mass, and P is final velocity is 16 meters per second and initial velocity is 0. You get from solving this one, you will get T from this equation. Though it works out, T is 16.31 seconds. 16.31 seconds. Next is that once it achieves a velocity of 16 meters per second, you are removing the force. After removing Newton force. Second step, substitute the same in the above equation. There is no force. There is only 150 Newton frictional force into T is equal to weight is same divided by 9.81 in the bracket, and it is retardation and minus 16. It is retardation. From 16 it goes on reduces. So therefore I will take it as minus. So minus of minus balances. You will get T is equal to, I hope same time is required because frictional force is 150 and this force is 300, so half of that. So you will get the same time. If there is difference in force, then you will get the timing will be different. This is how the problems are required to be solved. Now we'll take up one more problem based on this and see the time, how much time is left. 20 minutes is there, we will be able to solve one more important problem and then for the connected body. Okay. So this problem will be solved by both the methods. Okay. There are many problems are there on connected bodies. What are the important problems I am trying to solve it by using this one. Okay. Take down this problem regarding unconnected body, impulse momentum but unconnected bodies. This problem. Connected by string or wire, rope. How they behave, and there are two ways. The way I am doing solving now, independent freeboard diagram for each block, and then you can work out. It's a little bit lengthy, but all the parameters will be able to work out from that. Otherwise, if particular parameter is asked, then there is a direct way also you can do it, avoiding the tension in the string. If it is asked, then you have to do this. Now here you see it. Take the problem. This problem is solved by both the methods. Determine the time required. Determine the time required for the weights shown in the figure. Determine the time required for the weights shown in the figure to attain a velocity of 9.81 meters per second. To attain a velocity of 9.81 meters per second. Determine the time required for the weights shown in the figure to attain a velocity of 9.81 meters per second. What is the tension in the cord? What is the tension in the cord. What is the tension in the cord? Take mu is equal to 0.2 for both planes. What is the tension in the cord? Take mu equal to 0.2 for both the planes. Okay, no problem. Let's see it. This is one slope. This is little bit steep slope. Likely, I want to show it. Both looks same. This is how the slope is there. There is one block is suspended and it is there. Other block is suspended on this slope and it is also. And there is a frictionless pulley connected here and a string or wire is taken over that rope and connected to both the blocks. I call this block as A and I call this block as B. Two blocks, so that identification will not be any confusion. This weight of this block is 2000 Newton and weight of this block is 1800 Newton. Block B. This angle for both is this one. This is less steep with 30-degree slope. This is more steep with 60-degree slope. 30-degree slope and 60-degree slope. Now, this is the string. It is under tension, connected here. This is also under tension, connected here. Both the blocks are connected by string and hold like that. That side strip is more. Once you leave it, the block starts moving downward. Direction of moving I am showing you. It moves upwards. Okay? This is the direction. Because of that side, the steep slope, though weight is slightly less, but it moves downward. If my assumption concept is wrong, then I will make it negative answer. So therefore, don't worry about that. This weight is slightly less also, as it is very steep. The block, if you release from freedom, it starts moving downwards. It starts moving up in that direction. So the tension that during that point, there will be cable will be under tension, and what they have asked you is that what is the time required for the waves to achieve a velocity of 9.81 meters per second? So, you assume that the initial, are leaving it from freedom, initial velocity is 0 and it should achieve a velocity of 9.81 meters per second. It should achieve a velocity of 9.81 meters per second. These are things. So, one is you are required to work out time, second is you are required to work out tension in the cable. So, when these two parameters are asked, then I have to go the conventional method of applying equilibrium condition, dynamic equilibrium condition for block A, write an equation. For block B, write another equation. There are two equations, two unknowns. You can solve those two unknowns. Suppose if they ask you in the exam, didn't ask you tension in the cable, they don't want. What is the only time required for that to achieve that velocity? Then you don't need to go this lengthy process. You can write only one equation directly and you will get the time required for that, but you will not get tension. But if by chance you want to work out tension, write one equation for any of this one, already you know the time, substitute that, we will get the tension in that. Again, I will explain you after that. Now we will go ahead with it. First of all, we will draw the three body diagram for this one, so that you will be able to see it clearly. Now, as you know normally, well, first of all, I need to know what is the normal reaction. I call it as normal reaction Na, and there is a frictional force. As the block is moving up, there is a frictional force Fa is acting in this direction. Similarly, for this block moving downwards, the frictional force is acting in the upward direction, and normal reaction always perpendicular to the plane of the board, that is NB. These are the basic parameters I require to work out, and I will work out here only below, so that you can use directly for solving. As it is makes an angle of 30 degree, and perpendicular to the plane of the board, this angle will be 30 degree. Similarly for this also, this angle will be 60 degree for this. I hope I am convinced, otherwise by geometry you can work out that one. Okay? Now I need to work out what is Na for block A. Is component in this direction. Component will be in this direction is 2000 cos 30, and component in this direction is 2000 sin 30 for this, and Na is equal to 2000 cos 30. So that this one 1732.05 Newton, and Fa is equal to, they have given you mu for all the bodies is 0.2 into 32.05, will get 346.41 Newton. One factor I got for block A, and for block B I will work out here. This is very difficult. For B, NB is equal to this one. NB is equal to this is 1800 cos 60, similar to this, and component weight will be acting in this direction. So this is 1800 sin 60 height. Now NB is equal to 1800 cos 60, it works out 900 Newton, and FB is equal to frictional force 0.2 into 900 is 450 Newton. These are the basic parameters I have worked out. Now my equation next is that simply I have to apply equilibrium condition block A, equilibrium condition for block B in the parallel to the plane. So therefore dynamic equilibrium. So block A, can write dynamic equilibrium parallel to the plane, parallel to the plane. So therefore, I apply all the forces that are acting in this direction on this block only, restricted to that, so that tension is acting in the upward direction. I will take it positive, and weight component is acting downwards is 2000 sin 30 minus 2000 sin 30, and frictional force is opposing. Fa is also acting downwards. Fa is 346.41 minus 346.41. I think only these are the three forces acts on that in the horizontal direction. That should be equal to W by G or M. M mass is 2000 Newton divided by 9.81. I want mass into initial velocity is 0, final velocity is 9.81 I know the velocity what is required, initial is 0. You will get equation 1 from this. You will get equation 1 from this. That is, you simplify it, T minus 1346.41 into T is equal to 2000, equation 1. Similarly, for block B, there are one equation I got, but there are two unknowns. You apply the equilibrium condition for this in the parallel to the plane. So here also what I will do, T is acting upwards, F is also acting upwards, and this one I will take upward as this I have taken minus. I will take minus T upward and minus FB. FB is 450 Newton, and component of weight is acting downwards. I will take as positive 1800 sin 60. It doesn't make any difference, but we'll follow the same thing. Now write weight of this block is 1500 Newton. I think 1800 or 1500 it is. 1800. It is 1800 Newton and 9.81. This will remain same, 9.81 final velocity, and this is 0. You will get second equation. So simplify it, you will get the second equation as 1378.75 minus T into T is equal to 1800 Newton. Equation number 2. You got two equations, 1 and 2. There are two unknowns, so that you can easily solve. I will write in this form here. Solve these two equations, 2, 1 and 2 equations for two unknowns. You will get T as well as T is called T. So therefore T is 1363.48 and small t is unknown 7.11 Newton. Second, I hope you have understood this one. The same problem I want to solve it by, till time is there. Second method, just I will explain you. The same problem, whatever I have solved, I will explain you in this way, that if this one is not required, I don't want this time t, then I can do very simple way of doing this problem. I know all the parameters already you have given here, just I will remove all those things. I will write this equation, otherwise I will write here. I will show here only. Now, I don't want tension in the cable. They are asked in the exam, they are asked me to calculate what is the time required, that's all. So, then I can do it very fast, this one. I will, as this is connected by the cable, so